Welcome to the All Sorts podcast, where we ignite your curiosity and just dive deep into some of history's most fascinating mysteries.
You got it. And today we're going to be focusing on the Tunguska Event.
Ooh, yeah, that's a good one.
Yeah, so for every of you listening who are interested in this topic, we've gone through a bunch of first-hand accounts, scientific reports, all sorts of...
I mean, it's been over 100 years, and this is a mystery that is still captivating scientists.
For sure. So let's set the scene a little bit. June 30, 1908, 7:17 in the morning.
Early,
yeah. And the location is super remote.
like Siberia remote, right?
The Siberian taiga.
Okay, so we're talking way out there.
Way out there by the Podkomenaya Tunguska River.
That's a mouthful.
It is, and it was part of the Yenisast Governorate under Tsar Nicholas II back then.
Okay, so this is a really far-flown place.
Yeah, totally. So what happened there? Well, we have a bunch of crazy eyewitness accounts, and these accounts are interesting because a lot of them were from people who were really far away from the actual event.
Right, so it must have been huge to have been seen and felt that far.
Exactly. So we're talking local Avinki reindeer herders, for example. And these were people 20 miles away from the epicenter, and they saw this fireball streak across the sky,
Wow.
leaving a smoke trail and then a flash that was brighter than the sun.
So not just like a shooting star, brighter than the sun.
Way brighter, and then this just insane, earth-shattering, thunderous sound.
I can't even imagine.
And some of them even said they were thrown into the air, like physically.
Wow, that's a strong sound wave.
Yeah, their homes were damaged. Some of their reindeer were lost.
Yeah, that gives you an idea of the power.
Totally, the power and the strangeness of this event, because this isn't like a normal, earthquake or volcanic eruption or something like that.
Right, it's not like anything else.
Yeah, exactly. And then there's this guy, Seaman Stimanov, who was 65 kilometers to the south, which is about 40 miles. And his story is just wild. He said the sky split in two.
The sky split in two?
It split open, and there was this huge fire above the forest.
Like a giant crack.
Yeah, and he felt this wave of intense heat, and then the sky slams shut.
Like posing back up.
Yeah, and then this massive thump that just throws him several yards. He said it was like cannons firing, and the earth was shaking.
So not only visual, but also the sound and the physical force was incredible.
Absolutely, and to really understand the power of this event, you got to hear about Chuchan.
Okay, who's Chuchan?
He was from the Chinagir tribe, and he was near the river, close to where it happened. And he said he was woken up violently by this powerful wind and this whistling sound.
Like something rushing through the air.
Yeah, and at first he thought it was just birds flying overhead, but then he got thrown into a fire.
Like he was shoved by this force?
Yeah, something just pushed him right into the flames, and he talks about the sound of trees snapping and falling, his hut collapsing, and the sky becoming this second sun, so bright.
Oh my gosh, that must have been terrifying.
Yeah, and he even mentions hearing multiple thunderclaps.
Like one after another.
Yeah, it's just wild. And the effects of this event went way beyond just those who were close by.
So it wasn't just a localized thing.
No, not at all. We're talking people in villages over 200 kilometers away, over 120 miles, and they saw this bright bluish-white object in the sky shaped like a pipe or a cylinder.
That's really specific.
Yeah, I know, right? And it was slowly descending for about 10 minutes before turning into black smoke.
10 minutes? Wow.
They heard these loud knocking sounds, unlike thunder, and their building shook, and some people saw flames coming out of the cloud. There was widespread panic.
Yeah, I can only imagine seeing something like that out of nowhere.
So to give you some context here, seismic stations across Eurasia actually recorded tremors from this event.
So something in Siberia shook the ground thousands of miles away.
Crazy, right? And the air waves, those pressure waves from the blast, were detected in Germany, Denmark, Croatia, the UK, even in the Dutch East Indies and Washington, D.C.
So all over the world.
Yeah, it's thought that the shock wave was as strong as a magnitude 5 earthquake in some places.
That's a serious shock wave.
Yeah, no kidding. And it didn't stop there. The skies were doing crazy things in the aftermath.
What do you mean?
Well, for days after the event, the night skies across Asia and Europe were glowing.
Glowing how?
Like an eerie light. There are stories of people being able to read newspapers at midnight in Sweden and Scotland without any lamps or anything.
Wow, that's strange.
Yeah, and the Smithsonian Astrophysical Observatory actually recorded that the atmosphere was less transparent for months afterwards, probably because of all the dust and debris that got thrown up there.
So this was a major atmospheric event.
Absolutely. Now you have this huge explosion high above the ground. But what about the impact of the ground itself?
That's what I was thinking. What did it do to the actual landscape?
Well, the destruction was massive, 80 million trees just flattened.
80 million trees.
Over an area of 2,150 square kilometers, which is bigger than the entire city of London.
That is a lot of trees.
The crazy thing is the trees weren't just randomly knocked down. They were flattened in this radial pattern like spokes on a wheel pointing outward from the center.
That's so specific, it must have looked bizarre.
Absolutely. And that unusual pattern got scientists thinking that maybe this wasn't a typical impact.
Like a meteor hitting the ground.
Right, because the pattern of destruction was so unique. It had this butterfly shape. And in the very center, something really weird happened. The trees were still standing, but they were scorched black and completely stripped of their branches and bark.
Like skeletons of trees?
Yeah, they're called telegraph pole trees. And that level of destruction, but no crater. That's what really puzzled scientists.
It sounds like something out of a sci-fi movie.
It does, right? But you know what the really surprising thing is? It took a long time for anyone to really investigate this.
Why is that?
Well, think about it. It happened in 1908, and then you have World War I, the Russian Revolution, the Civil War. It was a crazy time.
Oh yeah, everything was in chaos.
Exactly. So it wasn't until 1927, almost 20 years later, that the first scientific expedition, led by this guy Leonid Kulik, actually made it to the site.
So what did Kulik think had happened?
He was a specialist in meteorites, so he was convinced that a giant iron meteorite had smashed into the Earth. But when he got there, he saw this giant area of flattened trees, but no crater.
No crater at all?
Nope. He spent years looking for evidence of an impact like meteorite fragments, but he never found anything substantial.
That must have been frustrating.
Totally. But later investigations did uncover some clues, like in the 1950s and 60s, they found tiny microscopic spheres in the soil and even stuck in the resin of some of the trees.
What kind of spheres?
They were made of silicate and magnetite. And the thing that was really interesting is that they had a really high nickel-to-iron ratio, which is something you often find in materials from space.
So this was evidence that something from space had exploded there.
Exactly. And the fact that they were tiny spheres suggested that whatever it was exploded in the air before it hit the ground, which is called an airburst.
Okay, so an airburst explains why there's no crater.
Exactly. And the mystery deepened even further when later analysis found unusual ratios of metals in those spheres.
Like, what do you mean?
They found weird variations in the amounts of different elements like carbon, hydrogen, and nitrogen in the peat bogs from that same year, 1908.
So something really unusual happened to the elements in that area.
Yeah, and some studies even found high levels of iridium in those peat bogs, which is an element that's pretty rare on Earth but more common in space rocks.
So more evidence pointing to space.
Right, but here's the thing. Not every lab that studied these samples found the same results. So it's still kind of a debate among scientists.
Ah, so more research is needed.
For sure, and we can't forget about the aerial photos taken in 1938. They flew over the site and took pictures of the destruction. Unfortunately, the original negatives got burned at a fire, but luckily they had printed some copies.
That's lucky.
Yeah, it gives a really clear view of how massive and how strange the damage was.
Okay, so putting all of this evidence together, what do scientists think caused the Tunguska event?
Well, the most widely accepted theory is that a stony asteroid exploded in the atmosphere.
Okay, so not an iron meteorite like Kulik thought.
Right, a stony asteroid, and it's thought to have been about 50 to 60 meters in diameter.
So like about the length of an Olympic swimming pool.
Yeah, and it probably detonated about 5 to 10 kilometers above the ground.
That's pretty high up.
Yeah, and it was moving super fast. They estimate around 27 kilometers per second.
That's like 60,000 miles per hour.
Yeah, way faster than a speeding bullet, and it was coming in at a shallow angle about 30 degrees from the east-southeast.
And the energy released by this explosion?
Oh, it was huge. Estimates are between 10 and 30 megatons of TNT.
Okay, for those of us who don't know about TNT, what does that actually mean?
So that's like hundreds or even thousands of Hiroshima bombs going off at the same time.
Oh, wow.
Or think of it like the eruption of Mount St. Helens. That's the kind of energy we're talking about.
That's incredible that something from space could have that much power.
Yeah, and the fact that it exploded in the air explains why there's no crater and why the trees were flattened in that radial pattern.
Right, because the shock wave would have traveled outward and downward from the explosion point.
Exactly, and those telegraph pole trees in the center, they were probably right under the blast, so they got hit with the full force from above, which ripped off their branches and scorched them.
So it all fits together.
Yeah, and scientists have actually done experiments where they detonated explosives above model forests, and they get the same kind of damage patterns.
So it's like a real-life science experiment gone wrong.
Yeah, kind of, but it really makes you think about the Chelyabinsk meteor in 2013.
Oh yeah, the one that exploded over Russia?
Right, that was much smaller than Tunguska, only about 20 meters across, but it still blew out windows and injured people.
So these kinds of things can happen and we might not even see them coming.
Exactly, which is why planetary defense is so important.
Okay, so we've talked about the asteroid theory, but haven't there been other theories about what caused Tunguska?
Oh yeah, there have been lots of ideas over the years, some more out there than others.
Like what?
Well, one of the early ones was the comet theory proposed in 1930 by an astronomer named F.J.W. Whipple.
A comet instead of an asteroid.
Right, and it makes sense because comets are made mostly of ice and dust, so they would vaporize completely in the atmosphere and wouldn't leave behind any big chunks of rock.
And that would explain why Kulik didn't find any meteorite fragments.
Exactly. And some people think that the glowing skies after the event were caused by ice crystals and dust from the comet spreading out in the atmosphere.
That's an interesting idea.
Yeah, and the Tunguska event happened around the same time as the Beta Taurida meteor shower, which is linked to a comet called Comet Encke.
So maybe a piece of that comet hit us.
Maybe. But there are some problems with the comet theory, too.
Like what?
Well, comets are less dense than asteroids, so they break apart more easily, and they usually come into the atmosphere at a shallower angle.
So they wouldn't have the same impact.
Exactly. They would probably disintegrate higher up in the atmosphere and wouldn't cause an explosion as low down as what seems to have happened at Tunguska.
So the comet theory has some holes.
Yeah. And then there's this newer theory called the glancing impact hypothesis.
That sounds interesting. What's that one about?
This one says that a really big iron asteroid, maybe 200 meters across, grazed the Earth's atmosphere, but didn't actually enter it completely.
So it just skimmed at the top.
Yeah, and this would have been at a slower speed in the asteroid theory, about 11 to 2 kilometers per second.
And how would that explain the Tunguska event?
Well, the idea is that even a near miss like that could still create powerful shock waves and heat up the air enough to cause the damage on the ground.
So no direct impact, just a close call.
Right, and it would explain why there's no crater or big fragments, but it's still a pretty controversial theory.
And what about those more out there theories you mentioned?
Oh yeah, some people have proposed that it was actually a terrestrial event, like a massive release of natural gas from underground, or a Verne shot, which is a theoretical type of explosion from deep within the Earth mantle.
Okay, so not space-related at all.
Right, but those theories don't really explain all the evidence we have, especially the stuff pointing to an extraterrestrial origin.
So those are probably less likely?
Yeah, and of course you always have the more fringe theories like alien spaceships or even a tiny black hole.
Well, those are fun to think about.
Yeah, they definitely capture the imagination, but they're not really taken seriously by scientists.
Okay, so back to the evidence we have. There's this Lake Checo that's been a bit of a puzzle.
Ah, yes, Lake Checo, it's about 8 kilometers northwest of where they think the Tunguska event happened, and some scientists believe that it could actually be an impact crater.
Really? From a surviving fragment of whatever exploded?
Exactly. In 2007, a group of Italian scientists proposed this idea.
And what's their evidence?
Well, Lake Checo has this bowl shape and a conical bottom, which is typical of impact craters. They also claim to have found a big rocky object under the lake using sonar, and the long axis of the lake points towards the direction the Tunguska object was coming from.
So it's lined up.
Right, and they took sediment cores from the lake, and they found a change in the layers around the time of the Tunguska event, like the first appearance of some aquatic plants.
Suggesting that the lake formed suddenly.
Yeah, but not everyone agrees with this theory.
There are always different opinions in science.
Exactly. Other scientists, mainly from Russia, have studied the lake, and they say it's way older than 1908.
How do they know that?
Well, one study from 1861 looked at the silt at the bottom of the lake and said it was probably thousands of years old. And more recently, in 2017, they did some soil analysis and looked at the contamination from nuclear weapons testing in the 20th century.
Wow, using nuclear testing to date a lake.
Yeah, it's pretty clever, and they concluded that Lake Checo is at least 280 years old.
So it seems unlikely that it formed because of the Tunguska event.
Right, and the physics of impacts don't really support it either. A small stony fragment wouldn't be strong enough to survive the atmosphere and then hit the ground with enough force to create a lake that size.
So it's still a mystery.
Yeah, but that's what makes it so fascinating, right? Even after all this time, we're still trying to figure out exactly what happened.
It really shows how powerful nature can be and how much we still don't know about our own planet and the space around us.
Absolutely, and events like this remind us how important it is to study and understand these potential threats from space.
That's where planetary defense comes in.
Exactly. It's all about identifying and tracking near-Earth objects, or NEOs, that could pose a danger to us.
And what can we do if we find one that's headed our way?
Well, that's where organizations like NASA's Planetary Defense Coordination Office come in. They were formed in 2016 to focus on this very issue.
So they're like the space guardians.
They work on developing technologies and strategies to protect Earth from impacts.
Like that DART mission I've heard about?
Yes, DART stands for Double Asteroid Redirection Test. It was a mission where they crashed a spacecraft into a small asteroid moon to see if they could change its orbit.
And did it work?
It did. They successfully nudged the asteroid, so it's proof that we could deflect these things if we need to.
That's pretty amazing.
It is. And, the anniversary of the Tunguska event, June 30th, is now International Asteroid Day.
That's fitting.
Yeah, it's a day to raise awareness about asteroids and the importance of planetary defense.
Because as Lindley Johnson, the NASA Planetary Defense Officer, said, and I'm paraphrasing here, a collision with a near-Earth object is the only natural disaster we can actually prevent.
That's a powerful statement. It really highlights why we need to keep learning about events like Tunguska and investing in ways to protect our planet.
So we've come to the end of our deep dive into the Tunguska event, and even though the most likely explanation is that a stony asteroid exploded in the atmosphere over 100 years ago, there's still so much we don't know.
Yeah, it's a reminder that there are these powerful forces out there that we're still trying to understand, and that we need to be prepared for whatever the universe throws at us.
Exactly. And for you, our listeners, we hope you enjoyed this journey into one of history's biggest mysteries. If you found this fascinating and you want to explore more captivating topics with us, then join us on the All Sorts podcast. We have a whole universe of deep dives waiting for you on YouTube, so go ahead and subscribe to our channel so you don't miss out on any new episodes.
And while you're at it, share this episode with your friends and family, and join the conversation on our other social media platforms like X, Instagram, and Threads. We love hearing your thoughts and ideas, and who knows, maybe you'll have a theory about the Tunguska event that we haven't even considered.
And as you look up at the night sky tonight, think about that remote Siberian forest and those millions of trees flattened by an unseen force. It's a reminder that even though space seems vast and empty, it's full of wonders and dangers, and it's all connected to us here on Earth.
And who knows what other mysteries are out there waiting to be discovered.
That's the beauty of it, all right. Well, thanks for joining us on a deep dive into the Tunguska event. And as always, stay curious.
And keep exploring.
We'll see you next time on the All Sorts podcast.
Bye, everyone.